On retake, okay, I'm covering the radians and algebra section, number 11 through 14 for both versions A and B. I'm going to do both, focusing on version A in the first half and then version B in the second half, but there's some overlap. So go ahead and skip to the part that applies most to you, as in any video. So let's start with version A. Convert the following angle measures from degrees to radians or radians to degrees. In order to do this, we must keep in mind what we know about converting from degrees to radians. How many degrees are in a radian? We need a conversion ratio. Okay, well, what do we know about the unit circle, or what do we know about radians? Okay, so you can use several different ratios, but the one I like the best is the fact that to get from here to here, that is 180 degrees, right? And then to get all the way back, full circle is 360. Well, a full circle is 2 pi radians, right? Which means a half circle is pi radians, okay? So we can use either of these. I guess this is the most simplified version, because if you divide this by 2, it's 180. Divide that by 2, it's just pi. So our conversion ratio is going to be pi radians over 180 degrees. Or you can say 180 degrees over pi radians. That's the same thing, because these are the equivalent. So if you divide by something that's equivalent, this is really, it reduces to 1. This reduces to 1. So when we multiply anything by this or this, we're just multiplying by 1, which means we're not changing the value, we're just changing the way it looks so that we can convert. Okay, so if we're converting from degrees and we want to end up with radians, we want to use this one, because we want the degrees to cancel out and we want to end up with radians. If we're going from radians to degrees, we're going to use this ratio because we want the radians to cancel out and end up with degrees. Okay, so this is just like conversions in chemistry. So we have a 75 degrees. We're going to multiply that, okay? Multiply, not using an equal sign. Equals what? We're going to multiply it by 1, okay? If we multiply it by 1, it's the same. What kind of one? Which one do we want to use? The one where we're going to have the degrees cancel out. We want the degrees to cancel out. So we want the degrees to be on the bottom, you see, because they're going to cancel. Well, 180 degrees is equivalent to pi radians. That way, when we cancel, the degrees are going to cancel. So what's left? Radians. The radians are left, okay? So we have 75 times pi, because that canceled, but this didn't cancel, that didn't cancel, that didn't cancel. 75 pi radians. Over the degrees units cancel, but the 180 did not. So how many radians do we have? We have 75 pi over 180 radians. Now that reduces, because we know that 75 is divisible at least by 15. Okay, 75 is 15 times 5. If you don't know that, now you do. 15 times 5 is 75. But don't forget the pi. And don't say, oh, I just have to stick the pi there because it's radians. No, the pi came from this conversion ratio. It's not a mindless trick. Okay? What's 180? How many times does 15 go into 180? Well, I guess I could divide. 180 goes into 15 goes into 180 once. And 30 goes into 15 twice. So 180 is 15 times 12. 15 divided by 15 is 1, and so we're going to get 5 pi over 12 radians, okay, for my final answer. Common mistakes that I saw, okay, were that people like to say 75 degrees equals pi radians over 180 degrees. No, it does not. And then they would say this, oh, 75 pi over 180. So even though you got the right answer, to me, you are making some, right, telling two truths and a lie, or two lies and a truth. You're telling so many lies that in the end you got to the truth accidentally. 75 does not equal pi over 180. Does not. Because this is 1 and 75 does not equal 1. You're multiplying, not saying it's equal. If you want to say something is equal, if you want to use, see, this was the chemist, I'm just going to call this the chemistry way. Okay? If you wanted to use the proportional way, okay, the proportion method, that's another one where you could, and if you don't care to hear the proportion method, you could go ahead and skip this. But some people like to say, hey, 75 degrees over what radians equals, then in this case, you don't cancel anything out. You want everything to be equivalent. You want degrees on top and radians on bottom. Or you could have radians on top, degrees on bottom, okay? Well, now 75 degrees over some radians should be equivalent to the ratio of 180 degrees over pi radians. So it's kind of like saying 1 over 2 should equal 2 over 4, right? Let's say you're converting from, like, maybe the recipe calls for like one egg for every 2 cups of sugar, right? Well, then you want to say, well, what if I have to use 8 cups of sugar? Then you want to know how many eggs to use, and you know that has to be a ratio of 1 to 2, so you know that has to be 4 to 8. So that's the proportion method. We're setting a proportion where eggs over sugar equals eggs over sugar, degrees over radian equals degrees over radian. So what is 75 to what is the same relationship as 180 to pi. And in that case, if you have equal proportions, that's when you can do the so-called cross multiplying, but I don't even like that to say that. 1 times 8 equals 2 times what? And so 2 times what equals 8? 2 times 4 equals 8. Okay? So in that sense, you can cross multiply. I don't even want to call that. I'm going to just multiply pi radians on both sides, because cross multiplying to me is just sacrilegious. Pi over radians cancels out. So now I have 180 degrees equals, okay, but the radians cancel out here. So I have pi times 75 times, or 75 degrees over what? I want to get that what by itself, so I'm going to take the reciprocal of both sides. Okay, and this is over 1. So what over 75 pi degrees equals 180 degrees. If I want to get rid of this, then 75 pi degrees on both sides. See, I think this is more complicated, so I don't do it. So what is my answer? That is not good. Oh, shoot. Sorry, I'm sorry. I had to take the reciprocal of this. Okay? And that's over 1. So really, this is going to be on top, 75 pi degrees over 180 degrees. Oh, and this was supposed to be radians, huh? And the degrees cancel out, and so I have, what radians do I have? 75 pi over 180. Again, I would steer away from this. The only reason I show this is if some of you have been doing it and you've been doing it wrong and you want to know where you went wrong. But I much prefer you use the chemistry method. Okay, it works for me every time. I use it when I'm doing cooking. I use it when I calculate my gas mileage. I use it for a lot of things in life where I have to convert, for example, the gas mileage of my car multiplied by price of gas, multiplied by how many miles I go, and I could figure out a lot of things that way. Okay, now if we're going from radians to degrees using the chemistry method, I want my radians to cancel out. So I want to do radians divided by radians. So I want to use this ratio. So I'm just going to multiply by 180 degrees per pi radians. Now, why am I allowed to multiply by this by something? Won't I change this number if I multiply it by something? Not if that something equals 1. Because 180 divided by pi, you're like, how does that equal 1? Well, 180 degrees is the same thing as pi radians. So they really are the same thing. And when you multiply something by something that's the same thing as itself, you get 1. So I'm allowed to multiply by 1. This is just a funny looking 1. Because now I have radians over radians cancel units. I'm only left with degrees. 1 times 180. And then I have 12. This was on the top, it got cancelled. And that got cancelled, 12 pi. Well, pi over pi is also 1. So I have 7 times 180 over 12 degrees. Okay, well I know that, remember earlier we talked about how 180 is 15 times 12? And degrees, I'm just going to use that. And so the 12s cancel. So I have 7 times 15. And 7 times 15 is 35. 105 degrees. Okay. Alright, if you want more practice, then we could go ahead to version B. And I'll do it a little faster now. So, negative 3 pi over 5. A lot of people forgot the negative and they lost a point. That equals, or not equals, I can multiply it by a ratio. That equals 1. I'm trying to cancel out my radians, so I want the radians on the bottom, and I want degrees on the top. How many radians does it take to make how many degrees? Let's go with 180 degrees as pi radians. The nice thing about this is that my radians cancel. I'm left with degrees on the top, and then I have negative 3 pi times 180 over 5 pi. My pi's cancel out, so I have negative 3 times 180 divided by 5 degrees. Let me cancel that out. Clear. Well, 180 is 15 times 12, and I know that 5 goes into 15 3 times high, 12 degrees, which means 9 times 12 is 108 degrees. Alright. Just in the middle of recording a video, so I will talk to you in a second. Okay, now if I want to cancel, now I want to convert from degrees to radians. I want my degrees, so this is degrees, right, to cancel out. So I'm going to put my pi radians, which is equivalent to 180 degrees. This is just 1, and I'm allowed to multiply by 1, am I not? The degrees cancel out. I'm going to be left with radians. 250 pi divided by 180 radians. Well, I could cross out the zeros because that's just 25 times 10 divided by 18 times 10, and the 10s cancel out. Right? 250 is 25 times 10. 180 is 18 times 10. Yeah. Okay, and then 25 is 5 times 5, and there are no 5s in 18, so I'm going to have to just leave it as 25 over 18 pi radians. Okay. All right. Let's go back to version A on the unit circle. Okay, on a unit circle, this is a special angle. So first of all, looking at the big picture, I know that I'm almost going full circle. I start at 0. This much is pi radians, and the whole circle would have been back here at 2 pi. Notice that the angle 0 and angle 2 pi are in the same place. So it's actually a periodic function. Okay, so we're almost going the full circle, so it should almost be at 2 pi, a little less than 2 pi. How much less than 2 pi, I wonder? This much less. Well, if you are clear visually, this is not a fourth of this little sector. It's actually a third. Okay, so it's pi over, okay, so a third of this, but that's not 1/3 pi, okay, because remember it takes a full half, it's a half circle to go pi. So really, if I break up this circle into this, okay, keep in mind this whole thing is pi. So to get to pi, how many times did I have to cross over? Once, 2, 3, 4, 5, 6. So I split up my pi into 6 pieces. So that means this piece right here is pi, 1/6 of it. Or you can say 1/6 of a pi, which means pi, right? This is 1/6 of a pi, because a full pi is here, a half pi is here, and this is a 1/6 of a pi, or pi over 6. You can't say that's 1/3. That's 1/3 of a half pi, but this is 1/6 of a full pi. There's my full pi, there's 1/6 of it, because here's 1, 2, 3, 4, 5, 6. So this is 1 pi over 6. This is 2/6 of a pi. This is 6, or a half. Why am I freezing here? Okay, this is 4/6 of a pi. 5, 6, 7, 8, 9, 10, 11/6 pieces of a pie. Or we can say 1/6 times 11 of my pi, right? Which is 11/6 pi. So this is 11 pi over 6. That's my answer. You could have also thought, well, the full pi is 2 pi. I mean, full circle is 2 pi, but we're just shy. How shy are we? Just 1/6 of a pi less than 2 pi. Well, okay, so that's my answer. Well, if I want to combine that, we need a common denominator. So that's really going to be 12 pi over 6. Because like if I had gone the full way, this would have been 12 pi over 6, which reduces to 2 pi. The full circle is 12 pi over 6, minus the 1 pi over 6, which is 12 pi minus the 1 pi is 11 pi over 6. Okay? What about over here? Notice I'm going in the negative or negative direction. Opposite. So this is going to be a negative, okay? A negative answer. Okay, I'm going not a full circle. I'm kind of going 3/4 of the way and then a little more. How much is a little more? Well, again, we're breaking up that circle into the same thing. So remember, I'm breaking up my circle into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. This is 12 pieces, but how many pies is the whole thing? It's 2 pi divided by 12 pieces, which means each piece is pi over 6. So this is pi over 6 again. If you know that that's pi over 6, then that means this piece right here is negative. This way is negative pi over 6, right? This is positive pi over 6. So this is negative 1 pi over 6. 2 pi over 6, 3, 4 pi over 6, 4 pi over 6, 5, 6, which by the way reduces to 1 pi, right? Because this is, oh, these are all negative though. That's 7, 8, 9, here's 10. Okay? And that's where I stop. So my answer is negative 10 pi over 6. Oh, but that reduces, doesn't it? 10 over 6 reduces to 5 over 3 if you cut them in half. So it's negative 5 pi over 3. How could that be negative 5 pi over 3? I thought those were 6. I didn't know they were thirds. Well, let me do this the same way, but break it up into thirds. Take the same question and let's break up this pi into thirds. Oh, I see, said the blind one. Think about it. Can we see that we can take bigger chunks instead of these tiny pi over 6 chunks? Can we just break up our pi, our half circle, our pi into 3 pieces? 1 piece. This is too angled. 2 piece, 3 piece, 4 piece, 5 piece, Ooh, that's kind of cool. Okay, so there's 6 pieces in all in the whole circle. The whole circle is 2 pi radians, but I broke the whole circle into 6 pieces, which means each piece is pi over 3. Which makes sense because this is half circle is pi, and I broke up my pi into 3 pieces. So if I'm going backwards from here, since it's 0, this is 1/3, 2/3, 3/3, 4/3, 5/3 of pi in the opposite direction. Alright, now I'm going to go ahead and do the rest of this on version B because they're pretty similar. Version A is the same thing. I think version A just doesn't have this problem. Okay, this is no longer radians, this is the algebra portion of it. Okay, I'm going to go ahead and first distribute this exponent. Oh no, before I distribute the exponent, why don't I take care of the negativeness of this exponent? So x over 6 is going to stay the same. I mean x to the 6th power, but we're going to multiply it by 1 over x cubed y to the negative 2 power. But now, all of this is to the 2nd power, positive 2nd power. And I took care of that by, yeah, if you want, actually this might be more comfortable for you, huh? Okay, that, I took put this into the denominator, and then that negative became a positive exponent. Which means now I can distribute that 2 here. There's more than one way to do this problem and still get the right answer. So 1 over, this is going to be y to the x to the 6th and y to the negative 4th. Hey, but that negative exponent in the denominator means I can move this into the numerator. X to the 6th times the y to the 4th moves into the numerator, and now it's no longer negative because it's switched. And we have x to the 6th here. But look, x to the 6th divided by x to the 6th, those cancel out. So your final answer is y to the 4th power. Okay, let's do this one. This is going to stay the same, but this negative 2, I'd like to put that into the denominator. So 3xy squared, maintain everything the same, except this time we're going to do 3 over 2, x to the negative 1, y, all of that to the positive 2 power. So that negative 2 became a positive 2, but I had to move it south to the denominator. Now you're going to take my exponents, I'm going to distribute them to every part of the product. So 3 cubed x cubed y to the 6th, I multiply those exponents. 3 halves, all of that squared. X to the negative 1 times 2 is negative 2, y squared. Okay. 3 times 3 times 3 is 27, x cubed y to the 6th. 3 halves times 3 halves, let's do that over here. Just, you know, squaring it, just expand it. That's going to equal 9 on the top and 4 on the bottom. Okay, well look, I have a negative exponent that's already in the denominator, so I could go ahead and move that to the top, okay? But now that negative 2 is going to become a positive 2 exponent. And then I'm going to keep my, see how it moved to the top? Now I'm going to keep my y squared. Oh, what do you know? There's 6 y's on the top, y, 2 y's on the bottom, y. 2 of the y's cancel out, so I'm going to be left, in the end, the top wins. There's going to be 4 y to the 4th power left. So 27, y to the 4th power left. Okay, that 2 cancels. Okay, now we have xxx and xx. So in the end we have 5 x's, x to the 5th, divided by 9/4. If I'm dividing by a fraction, I could copy, change, flip. So I could go ahead and say 27 times x to the 5th, y to the 4th. All of that, copy that, change my division into a multiplication, and flip my 9 over 4 to 4 over 9. Well, 27 divided by 9 is 3 over 1. So I'm going to have 3 times 4, 12. And there's my answer. Factor completely. These are so much fun. I love them. There's 2 terms here. They're being subtracted, so it's a difference. What is the greatest common factor here? There's a 6 that can be factored out of both. There's an a squared here and only one a here. So at most I could take out one a. There's b, okay, this is a squared. There's b cubed here and b to the fourth. So the greatest power of b I can take out is the third power. If I do that, what's left? The 6 got cancelled out, so that's, factored out. There was it was a squared, I took out an a, so I still have an a left. There were b times 3, 3 b's here, all of them got cancelled out, factored out, so that's it. Then what? 12 divided by 6 is 2. Factored out that a, so there's no more a's. There were b to the fourth, I factored out b to the cubed, so now I have one b left. So my answer is going to be, that's it. 6ab cubed times a minus 2b. Can I factor out this anymore? And this is already fully factored, and there's my answer. Beautiful. Now this one, before we factor anything, we always check to see if there's any any common factors, and there is. There's the 7 as a GCF, so the greatest common factor is 7. I'm going to factor that out first. So I have s squared minus t squared. A lot of you guys left that there because you forgot from Algebra 1 the difference of squares. Difference of squares, you must know this. Difference of squares. If you have a squared minus b squared, that factors out to a plus b times a minus b. So s squared minus t squared, don't forget the 7, that stays there, but this factors to s plus t and s minus